right, good morning. Good morning, good morning. Good morning, ladies and gentlemen. All right, today we are looking at some logarithmic equations. We're going to basically be doing logarithmic equations all week long because they get more complicated. So today is the easy day. You should know that I'm not going to be here tomorrow. Excuse me. You will get a worksheet. You get done, finish it up, turn it in, and then you're free to work on whatever you need to work on. Just hope that you use your time wisely. And then for the rest of the week, we'll be just working on more logarithmic equations. It's kind of bad. We get back after spring break, and you'll have to remember all of this stuff, okay? So keep that in mind. There'll be just a couple more days, and then a test on logs. So to review, what is log base 2 of 32? What is it? 5. 5. Why is it 5? I heard people 2 to the power of 5 gives us 32. So in order to do logs, you have to know your powers. If you don't know your powers, then this is really, really hard. What about log base 3 of 81? What does that equal? Oh, 4. 4 is correct. Why? 3 to the 4th. Whoops, that's not written correctly. 3 to the 4th power equals 81. Very good. All right. Ladies and gentlemen, what is log base 7 of 1 equal to? 0, because 7 to the power of 0 always equals 1. And what is log base 12 of 12 equal to? 1, because 12 to the first power is always itself. Anything to the first power is always itself. Okay, so it is so important that you remember that whenever you have a log, you give it a swirly, and that helps a lot, okay? Today we are using 2 different methods to solve log equations. So we're learning 2 things. This is the one-to-one property again. We've used the one-to-one property before. If I had like 2 to the 7th equals 2 to the x, then what do you know? If 2 to the 7th is 2 to the x, what else is true? X must equal 7. If the bases match, then the exponents must match, okay? We used the one-to-one property with exponents. It works the same way with logarithms. If the logs match, then the arguments must match. U must equal V. And so that's the one-to-one property, and it applies here for logarithms. So if you have a log equal to a log, it's super easy to solve. The other thing that we're doing is isolate and exponentiate, which I kind of like the rhythm of. It sounds kind of cool. Exponentiate is a very mathy word. That is the actual math language, isolate and exponentiate. We don't solve log equations. We convert them to exponential form, which is what we do when we're giving it a swirly. We're actually rewriting it in exponential form. That's what we do if we have a single log. So today we have the one-to-one property, and if we have a single log, we're going to isolate and give it a swirly. Okay, so 2 things we're working on today, a one-to-one property and the single log swirly. All right, here we go. Example 1. Solve each equation and check. Checking is very, very important. Most of the time, the checking can be very, very easy. The one thing that you have to look out for is we cannot take the log of a negative number. That is not possible. Whoops, P-O-S-S-I-B-L-E. We cannot take the log of a negative number. So you can try it in your calculator. Log of negative 24. And you can see what happens. It gives us a non-real result. It gives us an error. It does not work. So we want to look out for, we're going to take our answers and plug them back in. And what we want to double check is just really to make sure that that argument, the thing inside the logarithm, the thing that's trapped, isn't negative. All right? As long as it isn't negative, it's going to work for us. All right. So solve each equation and check. What does this thing mean? What is that weird thing? Log base E. Very good. This is called natural log. I hear a lot of chatter, ladies and gentlemen, which is very frustrating for me and makes notes take longer. So please listen attentively. Thank you. This is natural log or log base E. And so I like to change it out for now so that we remember what it really means. Natural log is the same as log base E of 4x minus 11. Now, what situation? Is this the one-to-one property or is this the single log situation? This is one-to-one. This is the one-to-one property because we have a log equal to a log. If the logs match, what must be true? U is equal to V. The arguments must match. Whoops. 4 minus x must be the same as 4x minus 11. If the logs match, then the stuff should match. Log equal to a log is the one-to-one property. Okay. How are we going to solve? We need to get like terms together. So what do you want to do? Okay, I heard add 11. I can do that. Let's add 11. So we want to get our like terms on the same side. So we can add 11. 4 and 11 makes 15. All right, what else can we do? Add the x. We need the x's together. Negative x and positive x is 0. Leaves the 15 on the left side. And what is 4x plus 1x? 5x. And then we need to divide by 5. So we get x equals 3. As a possible answer, which we need to check. So I'm going to take that value of 3 and plug it right back in. And I have the natural log of 4 minus 3 is supposed to equal the natural log of 4 times 3 minus 11. The nice thing is you have a natural log button on your calculator. Granted, these numbers are pretty easy, right? What is 4 minus 3? 1. And here, 4 times 3 is 12 minus 11. 12 minus 11 is 1. Does the left side balance with the right side? Yes, it does. You can also plug it into your calculator. The natural log of 1 is 0. And that works just fine. 0 equals 0. They balance. The other thing is that argument there is a positive number That is a positive value. That's what we care about. Inside that logarithm needs to be positive. Okay, if it's negative, does it work? No. Inside those parentheses needs to be positive. That's the thing. Okay, over here we have letter B. Log base 8 of negative 6x minus 2 equals log base 8 of x squared minus 18. What situation is this? One-to-one property or single log? One-to-one property. Log base 8 is equal to log base 8. If the logs match, what must be true? Then u equals v. The arguments match. So negative 6x minus 2 is equal to x squared minus 18. What's different about these equations? There's an exponent. Yeah, this is a quadratic equation because of the x squared. How do we solve quadratic equations? You have to set it equal to 0 and then try and double bubble. Okay, so we want to move everything over to this x squared side. So I want to go ahead and move this stuff over. So I'm going to add the 6x to the right-hand side. I'm also going to add 2 to the right-hand side so that I get a 0, so that everything is on one side of my equation. I have an x squared. It didn't have a like term. I have a positive 6x. It also didn't have a like term. But negative 18 plus 2 gives me what? Negative 16. Very good. So we're going to set it equal to 0, and then we need to double bubble. Factor that. What times what is x squared? X times x is x squared. Last times last has to be negative 16. What times what is negative 16? Negative 4 times 4. What else? 8 times negative 2. Oh, that's a good one right there. So a positive 8 and a negative 2. How do you know if you did it right? Check the rainbow. So we have x times negative 2 is negative 2x. 8 times x is 8x. And that middle term works when we check the rainbow. All right, what do you do next? Okay. You set each bubble equal to 0. X minus 2 equals 0. X plus 8 equals 0. I love this lesson because it's a great review of everything we did first semester. All right. What does x equal? Negative 8 and positive 2. Possibly. Possibly. Why possibly? Because you need to check. Ladies and gentlemen, this is where you're going to get things wrong on test day. I'm going to give you, it's possible that both answers work. It's also possible that only negative 8 works. Or only 2 works. Or it's possible that neither answer works. So please make sure that you check your answers. So you need to check both answers. So we need to check x equals negative 8, and we need to check x equals 2. So I'm going to go back to my original, and I'm going to plug them in. Log base 8 of negative 6 times negative 8 minus the 2 is supposed to equal log base 8 of negative 8 squared minus 18. So I can do this inside parentheses here. What is negative 6 times negative 8? What's 6 times 8? 48. Thank you. Minus 2? 46. And we want to know, does that equal the right-hand side over here? What is negative 8 times negative 8? 64. And 64 minus 18 is 46 also. I used my calculator. Do they work? Yeah. They do balance. The left side is equal to the right side, but the real thing here is that this number inside the logarithm is positive. That is the key. As long as it's positive, it's going to work for us. So let's see what happens when I check negative, or when I check 2. Log base 8 of negative 6 times 2 minus 2 is supposed to equal log base 8 of 2 squared minus 18. Now, when I look inside my argument here, negative 6 times 2 is negative 12. Minus another 2 is negative 14. Need I continue?
No.
No, because that is a negative number. The argument is not allowed to be negative. And even though 2 squared is 4 minus 18 is also negative 14, even though the left and right side balance, we cannot take the log of a negative number. Not possible. All right, so 2 is a false solution. Only the negative 8 works, okay? So the real key here is making sure that whatever's inside the argument has to be a positive result. Negatives don't work, okay? And again, if you when in doubt on your calculator, try it. Log of negative 14, non-real, error. Doesn't work. Your calculator hates that. Okay? All right, questions on letter B. Last 2. All right, letter A and letter B were examples of the one-to-one property, where you have a log equal to a log. Do we have that here? No, we do not have a log equal to a log. This is a single log. There it is. There's the single log. So swirly. Isolate and swirly. Isolate and swirly is the process. Isolate and swirly. Single log, isolate, and swirly. So we have 3 log base 5 of x plus 2 equals 6. Isolate means that you need to isolate the log and whatever is tracked. Okay? What do we need to do to isolate that logarithm? Divide by 3. Divide by 3. That gives me log base 5 of x plus 2 equals 2. Now, we do not have the one-to-one property. Ladies and gentlemen, how do you drop a log? Swirly. See how that phrase just keeps coming back? We have log isolated. To solve it, we have to put it in exponential form or exponentiate it. To do that, we give it a swirly. 5 to the second power is equal to x plus 2. You cannot just drop the log and wind up with x plus 2 equals 2. Lots of you want to do that, but it doesn't just disappear. You have to do something to get rid of it. And that is the swirly. Give it a swirly, and it disappears. What is 5 squared? 25. Very good. So we have x plus 2 equals 25, and then how do we isolate x? Subtract 2. So we get x equals 23. Possibly. I'm going to go ahead and check that answer. 3 log base 5 of 23 plus 2 is supposed to equal 6. And again, I'm going to work through this. You can actually work through. 23 plus 2 is 25. What is log base 5 of 25? It's 2. 5 to the second power equals 25. So give it a swirly. That makes perfect sense then. And 3 times 2 does, in fact, equal 6. So you can work it all the way out, but I would have stopped right here. As long as inside that argument is positive, it's going to work fine, as long as you did your math right. Good. Always good to check your answers. All right, last one here. Negative 23 plus log of x minus 4 equals negative 23. Is this the one-to-one property or the single log? Single log. How long is single log? Sorry. Okay. All right. So again, it's a single log, so we want to isolate. How do we get this log by itself? Add 23. Oh, all of a sudden I'm hungry. Log of x minus 4 equals, what is negative 23 plus 23? 0. Very good. All right, single log. How do you drop a log? Give it a swirly. Whoa! What's my base? 10. This is the common log that you do have on your calculator. So if you need to, make sure you remember that if there is no base visible, then it's a base 10. So we're going to give it a swirly. So 10 to the 0 power equals my argument. What is 10 to the 0? 1. So we have x minus 4 equals 1, and then we need to do what? Add 4. So we get x equals 5. And again, I'm going to check it. Negative 23 plus log of 5 minus 4 is supposed to equal negative 23. I'm going to go ahead and use my calculator. And I can do that because it is log base 10. So I can actually put this whole thing in my calculator. All of you can. 23 plus log of 5 minus 4. Oops, I want to put that in parentheses. There we go. And what's it supposed to equal? Negative 23, and it does. So anytime you can plug it into your calculator, that is the easy thing to do. All right. You guys have any questions for me? Up. That one? All right. You guys have class practice 42 coming at you.